Hello everyone. I am Mrs. Usha Jadhav, Assistant Professor, D.Y. Patil College of Engineering, Akkudi, Pune. Welcome to this International FDP on Environment and Sustainability PO7. In the week 1, I have covered the role of semiconductor industry for environment and sustainability, in which we have discussed what is the use of semiconductor chips, what are the different environmental indicators like eutrophication. We discussed the environmental impact of microelectronic chips and then we have concluded. This is the overview of my week 1 video details. In the week 2, this is the outline of my week 2 where we are going to discuss about the environmental awareness of semiconductor industry and its impacts, and the need or the purpose of the various ISO standards used for semiconductor industry. So out of various ISO standards, especially the ISO standard 14031 1999 and its motivation, we are going to discuss general phases of microelectronic component life cycle, followed by expert ranking of environmental concerns in manufacturing plant and in design center, result of the various case studies, and then conclusion. Important thing is that in a semiconductor industry, the day-to-day life, the integrated circuits like the chips are used for various applications like mobile phones, computers, laptops, portable devices, iPads, and so on. So the main ISO standard which is used for an semiconductor industry is ISO 14031 and 1999. So which is nothing but an used especially environmental management, environmental performance evaluation. So environmental performance evaluation, the subject of this international standard, is an internal management process and tool designed to provide management with reliable and verifiable information on an ongoing basis to determine whether an organization environmental performance is meeting the criteria which is set by the management of the organization. So what are these environmental performance evaluation assists the organization? It assists for identifying the environmental aspects, determining which aspects it will treat as significant, setting the criteria for its environmental performance, and assessing its environmental performance against these criteria. Thus, an organization with an environmental management system in place should assess its environmental performance against its environmental policy, objectives, targets, and other environmental performance criteria. When an organization does not have an environmental management system, this environmental performance evaluation can assist the organization by using these listed criteria. So this environmental performance evaluation, that is EPE, include environmental reviews and especially the life cycle assessment. So this life cycle assessment is defined as the powerful technique to present a global vision of the impacts generated by products. The guidance on this your LCA, that is life cycle assessment, is provided by the various ISO standards like ISO 14040, ISO 14041, ISO 14042 and ISO 14043. The reason for considering all these aspects is to avoid the impact transfers, which attempts to improve one type of impact can deteriorate the another one. So like in a chip design, as we are focusing on 3 different types of performance parameters as area, power consumption and time. We'll have always the trade-off amongst them is nothing but if the chip area is going to increase, so automatically the power consumption will increase. And at the same time, there may be a chances of the delay which is going to reduce. So always there is a trade-off between these 3 parameters in a chip design, which is nothing but the impact of this manufacturing industry. So let us consider what are the different LCA, that is life cycle assessment agencies, are involved for that is environmental performance evaluation. So like that is this environmental performance evaluation which is initiated by using the life cycle assessment is, that is European Union, that is SIDING and SIDIC 2000s, which is nothing but a restriction of the use of certain hazardous substances, which is a 2002A version of European Commission. Also it includes waste electrical and electronic equipment, that is European Commission 2002B, and eco design of energy using products, that is European Commission 2005. So what is the motivation for this standard? As this standard is not certified, but it should be applicable for an semiconductor industry to calculate the environmental performance evaluation. So the main motivation behind this is nothing but today we are concerned about that is nothing but there are some generic stakeholders are always considered in a manufacturing industry, and they are materialized by demands from extra financial making agencies. As in a chip design, everyone knows that a photolithography process which is required to manufacture the integrated circuits and which is very costly. So always there is a main role of a generic stakeholder which is demanding the extra financial making agencies. So these agencies deliver ethical indexes like the Dow Jones Sustainability Index, and it reports on three major themes. What are they? They are nothing but the climate strategy, water related risk, and hazardous chemicals. So this is the first main motivation behind the standard. Second one is nothing but as electronic and computer industries are historically growing, and the customers of this microelectronic industry uses these various new applications like electric and electronic devices. Example is coffee vending machine in cars, in ink cartridges, light bulbs, medical applications, etc., which will integrate the electronic applications. The diversity of these customer markets tends to multiply the environmental obligations. First of all, the electronic sector as a whole has been facing an increasing problem of electronic waste, leading to the legislative frameworks. Thus, an industrial applications that need to evaluate the environmental potential of consumer products, incorporating the semiconductors. The third motivation is nothing but after production, as everyone is nothing but concerned with the development of once the chip is developed, it should be given to the consumer through its various applications. So the microelectronic associations that have decided to take the lead on environmental concerns in their own industry. Example is there is an International Technology Roadmap for Semiconductor, that is ITRS, is having its own standards, so that the microelectronics, this is one of the important association, they have decided to take the lead on environmental concerns, so that there should be a less that is hazards to the society. So these are the three important motivations behind this ISO 14031. Now let us discuss what are the general phases in microelectronic component life cycle. So this is the general diagram is shown, where you can observe at the center there is a chip and packaging, means there is a separate industry is related with the manufacturing of chip, and the separate industry is concerned with the packaging of your chip. So once for manufacturing of our chip, there is a need of some pre-treatment is required, like oxidation and all using the silicon. And apart from this pre-processing, there is a need of some raw material which is required, and it performs some processing like production, extraction, foaming, refining and all. So they required, while performing all this processing, they need not only the material input but also they require some electricity production. So by considering this total whole life cycle, where the chip manufacturing and the packaging of this, and then it is given to the end consumer, it includes the different 5 stages. First stage is your supply chain plants, including the mines, then microelectronic plants, then it includes downstream customer plants, and then location for use of the application, like whether you are going to use that application in a house or in a car, or the location for the end of life, like landfill, that is recycling plants and etc. So like this is the component life cycle of your microelectronics industry takes place, and this may be divided into a front end and the back end. Front end includes only the verification of the chip, while the back end, it is how we are going to provide this chip to the end customer or the consumer. So then next, we will discuss about what is the expert ranking of environmental concerns of manufacturing plants. So in the previous lecture, we have discussed what are the different indicators is used for assessment or the impact of this semiconductor industry in the society. So by considering these impacts, so example is the toxicity in water. It indicates in the front end sites and in the back end sites. So this plus twice it indicates that it will have some negative impact. But the global warming compared to the toxicity in water will have the more negative impact. So you can observe that for a global warming, that is perfluorocarbons, that is PFCs, or indirect energy emission. So there may be a direct energy emission or the indirect energy emission takes place as a global warming in case of the semiconductor industry. So this PFC will indicate the level of severity which depends on the efficiency of the material, which is nothing but perfluorocarbons, which we are going to use in a treatment plant. So there is a need of it indicates that there is a need of the extensive use of electricity is required. So resource depletion is nothing but again it is high negative impact in the front end as well as in the back end sites, that is intensive use of raw material. Water stasis comparatively it is less in the back end especially, but in the front end again it is having the major impact. So next we will observe that that is toxicity in water, global warming. You can see the shades, which is nothing but the highly gray shades are there, which is have the more impact on the society or the environment. So the next one is water acidification will have again that is reported it is especially 0, but will have some in the front end and the back end. So eutrophication is nothing but many acids which is consumed while processing of the integrated circuits. Then air acidification is there, summer smog is there, human health is there, and there is a waste which is going to come out of this the semiconductor industry. And again there is no influence of this semiconductor industry especially on a noise, ozone layer depletion, toxicity in air, land occupation, toxicity and smell, because the size of this ICs is very small. So this is all about the expert ranking given by the environmental concerns in manufacturing plant. So to conclude, today we have discussed that especially what is the life cycle, what are the different ISO standards used in semiconductor industry, followed by we have discussed life cycle assessment of your microelectronic industry, and what is the expert ranking given by the various researcher. So to conclude with this, that is what is the environmental impact or how we can go more aware about the semiconductor industry while using the devices or the appliances at home or in a car. So a standardized method is needed for us, that is which includes the environmental characterization of microchip technologies is necessary to compare the performance of different products and specify the product profiles. A suitable set of LCA indicators strongly contribute to increase the life cycle knowledge of the chips, and they must be accepted by international scientific community, be stable and induce reasonable constructive remarks on the main contributors to impacts. So these are the various references which are highlighted. So thank you very much.